Good afternoon, good evening, or good morning, wherever you are joining us from today, and welcome to another Reactor Livestream event. My name is Michael Watson, and I lead the Microsoft Reactor program in the Asia Pacific, and it's my great pleasure to welcome you again. Today, I'll be joined by both Nur Fathiha and Sahan Disanakia, both Microsoft student ambassadors, and they will be talking to you about how we skill up with MLOps with Azure. I encourage you to review their biographies on the registration page if you have not, as they have so many credentials and expertise that it will take me too long to read through them now. I'd like to draw everyone's attention to the Reactor Code of Conduct. Now, if you haven't seen this is on our website and on our meetup page. And in short, it basically tells us to make sure that we have a safe and enjoyable environment for this stream. So please be respectful with your comments and questions and make sure they're constructive and welcoming to all attendees. So let's get into it. And please do share your questions and thoughts in the comments section, and we will endeavor to answer as many of those as we can. I'll also be adding additional links into the Q&A chat session around our survey and other things to try and get some better information from you as our guests joining us. But for now, I'll hand over to our fantastic presenters, and they will lead you through this incredible session. Welcome to the stream is Nur and Sahan. Hello, both of you.
Hello.
I will now hand over to Nur, who is going to lead you on the first part. Thank you.
Okay, is my screen visible?
It sure is.
So hello everyone, welcome to today's session. We are going to talk about how to scale up with MLOps with Azure, and this incredible session is presented to you by Sahan Disanaika, who is a Gold Microsoft Learn Student Ambassador from Sri Lanka, along with me, Nur Fathiha Tahiat, a Gold Microsoft Learn Student Ambassador from Bangladesh. So yeah, Sahan, would you like to introduce yourself?
Yeah, why not? So hi everyone, I'm Sahan Disanaika. So as Nu said, I'm Gold Student Ambassador, and also I'm both compact with both research and development. So currently I'm a researcher at COSTAB, University of Colombo School of Computing, and also a research collaborator at AIT in Sri Lanka. And also I'm currently working as a data science engineer at ISA. So if you want to contact me, so these are my social handles. I'm both available on LinkedIn, Twitter, and also this is my student ambassador email. So over to you, to Fathiha.
Yeah, nice to know that. And here is me, Nur Fathiha Tahiat Seeum. I'm a Gold Microsoft Learn Student Ambassador. Currently, I have 5 Microsoft certifications, and I'm doing my graduate studies in the Department of Computer Science and Engineering at BRAC University. As of career, I'm working as a senior manager in the Department of Research at a very renowned organization at Bangladesh named Bangladesh Extension Education Services. So here below, you can see my social media handles along with my student ambassadors mail. So make sure to reach out in any case of, like, if you need any sort of assistance, I'd be there to help. So let's get into our topic. So what's coming here? So we will be getting familiar with the basics of ML with me. Therefore, Sahan will help us with a case study, MLOps case study. Then we will build an ML model with Azure Machine Learning Designer. And then Sahan will take the flow and deploy the model, and he will show us an orchestration of the ML model deployment. And lastly, we will quickly wrap up with some cost management tips. So yeah, at this point of the session, in which category do you consider yourself being? Like, if you are a person who is feeling like he or she, you like have some sort of knowledge, but you're too afraid or shy to ask, or you're someone who's like, whose head is full of knowledge and who's about to explode almost. So let us know in the chat. Now, let's start with our topic. So yeah, what's machine learning? You know about all the hype that's going around with artificial intelligence, right? So what's artificial intelligence? It's a broad area of knowledge with with the fields of machine learning, computer vision, neural networks, deep learning, and so on. So machine learning, it's at the very core of artificial intelligence. So here we can see an definition by Stanford University. It says that machine learning is the science of getting computers to act without being explicitly programmed. So what we mean by act, like how do we want our systems to act without being explicitly programmed? So we can see another definition by Udacity, which says that machine learning brings together computer science and statistics to harness that predictive power. So now we get some sort of idea that what we want our machines to do, we want to harness that predictive power. So is computer science and statistics enough to harness that predictive power? Does it involve anything else? So here we can see that like machine learning, it involves programming, statistics, mathematics, and intuition. So if you are someone who's working around data science, you must know that intuition is the one thing that helps us to go the long way. And yeah, here we can see another definition that machine learning, it's a data science technique that allows computers to build models based on sample data in order to make predictions or decisions. So we want to harness our decision-making ability with our prediction powers. So what are the approaches of machine learning? There are various approaches, but among them there are a few. We are going to talk about these four ones. So first of all, we have supervised machine learning. So whenever we're talking about supervised machine learning, one thing we must remember is that the data set we have is a labeled data set. So whenever we're working around supervised machine learning, we will be working with labeled data set. So here, the computer, it is presented with example inputs and their desired outputs. So the goal is to learn a general rule that will map the inputs to outputs. So if you are a little bit confused, we are going to have some examples. So there's nothing to worry. And in case of unsupervised machine learning, we must remember that the data set, it will be unlabeled. So no labels are given to the learning algorithms, and we will leave it on its own to find the structure or patterns, to discover hidden patterns within the data, or we can also use unsupervised learning for feature learning. Another approach that we have is reinforcement learning. So in reinforcement learning, a computer program, it interacts with the dynamic environment, and where it performs certain activities to achieve a goal as it navigates to the problem space, and it also is driven by some feedback, like with the rewards and punishment system. So one very famous example of reinforcement learning goes like, suppose we have a baby of 1 year at our home. So he or she, it sees fire. So from a distance, he feels like, yeah, fire is something so shiny and glittery. So what he tries to go near the fire. So as he goes towards the fire, what happens? He or she feels heat, and from that, he or she will understand, no, it might look so beautiful, but it's dangerous. From that punishment that he or she received, from there he will not try to go towards fire anymore. So that's the concept of reinforcement learning. And we also have semi-supervised learning. So in semi-supervised learning, we have a portion of labeled data, and compared to the volume of the labeled data, we have a bigger portion of unlabeled data. So with a combination of labeled and unlabeled data, we train our model and semi-supervised learning. So here are some examples. Suppose in this case, and the supervised learning example, we fed our machine with some pictures of cats, some different types of cat. So from there, we train our model, and after that, we can test our model with some other pictures. So here, we can see that there are two pictures of cat, and one, it's not a cat. And yeah, we can say that it's a dog. So what happens is our system, it can classify the pictures of cat as labeled cats. But in case of the other animal, it labels the pictures as not cats. So we can use supervised machine learning in case of classification problem, where we can use algorithms like two-class logistic regression, or we can also use supervised machine learning in case of regression problem. So where we identify real value or we predict value based on our past data. Okay. So in case of unsupervised machine learning, we already discussed that the data set we will be handling will be an unlabeled data. So here we fed some pictures of animal and the machine doesn't know which one is a cat or a dog. So after the training, our system, it will produce two cluster. So similar group 1, which includes the picture of cats, and similar group 2, where we can say that it's a group of dogs. So from here, we can understand that we can use unsupervised machine learning from clustering problem, just like we did here, and we can also use it for anomaly detection. Now, let's come to why we should use Azure Machine Learning. So Azure Machine Learning, it's a cloud-based environment where you can train, deploy, automate, manage, and track your machine learning model. So monitoring is much simpler with Azure Machine Learning. And it can also be used for any sort of machine learning, like from the classical ML to deep learning or supervised or unsupervised learning. And in this case, you have the full flexibility to write your own code in Python or R code with the SDK, or you can also go for the options like low code or no code deployment. So we will be having a demonstration on this in a minute. And with Azure Machine Learning, you can also start training your local machine, training on your local machine, and then scale out to the cloud. So you can achieve a scalability in Azure Machine Learning. You can either scale in and or scale out. So you also get the elasticity. And one thing we must mention is that in Azure Machine Learning, you get a pay-as-you-go service. So you have to pay for only those instances, the compute resource or the memory resource that you choose. You do not have to pay for the resources you do not use. So yeah, with Azure Machine Learning, we can get services, AI services for any skill level. We have automated ML where we just have to upload our dataset and we can select the algorithm on which we want to train our dataset, and voila, we will have our model trained. In Designer, we will have the full flexibility to drag and drop our data sets or our algorithms onto the designer board, and we will have our pipeline ready. And in case of notebooks, if you are a coding pro, you can write your own code with your own freedom. So yeah, that's what we just discussed. So if you have no code experience and no ML experience, you can explore automated ML. But if you have some sort of experience with both, you can go for ML Designer. And if you're a pro, is your notebooks is waiting for you. So at this point, I would like to invite Sahan to have the spotlight and enlighten us what's MLOps. So Sahan, are you there?
Yeah, so that is one of the best experience that you can get about ML from Fadia. So,
Yeah.
students. So in my part, so my core objective is to educate yourself about the newest trend out there about ML, and which can achieve a lot of performance at large scale ML models and large scale applications. So the reason behind why I just thought about it, because the ML is vastly evolving with trending fields like computer science as well as in the industry right now. And as students, we must be industry ready. And also to widespread our knowledge and the learning curve as MLSs, we are very much pleased to share our new knowledge with you. So let's move on with the ML life cycle. So, as you might know, so there are tons of taxonomies of ML lifecycle. This is somewhat a generic model of ML lifecycle. So let's assume we are inside a shiny tech company in an ML team. So at first, so data scientists and ML engineers and data engineers come to the picture. So at first, data scientists need to prepare and training our data. It's often the biggest time commitment in the whole pipeline. So trust me. So the preparation, including the standardization and the data, and which we couldn't usable in format and identify discrete variables and features. And then we are applying the algorithms to data to train our machine learning models. And then after, we are testing our model with the new data and see how accurate our predictions are. And then after, we are moving to the next stage, which is the packaging our model. So in this case, we are basically the ML engineers come into the picture. So we are basically using containerization options like Kubernetes, which is environment, which means creating a Docker container for the model and run its all dependencies in one place. And the model environment include the metadata like called libraries, dependency, as I mentioned earlier. Model needs to execute seamlessly. And then after, we are validating it. So at this point, the teams evaluating how our model perform compared to their business goals. So for an example, a company might want to optimize some software accuracy for a certain case. So in that case, we are measuring our performance with our business goals. So it's better to mention, right, in those three models or in first three steps are repeatedly doing in the business in usual cases. So it takes hundreds of training hours to find a satisfactory model. And then the development team decides whether to move on with this model, and they are deciding which model to we are moving on. And then we are basically deploying it finally and to the cloud using Azure or something like that, and using a on-premises server or a edge device like a camera or a IoT gateway or a simple mobile device. And thereafter, we are monitoring and retraining it. So even if our model is perfectly well performed, it needs to be continually monitored and retrained in order to reach our business goals. So as you may understand, so there is no such problems. So no, there are a lot of problems. So in here, we will not talking about everyday doing small kind of projects like we are just experimenting in Kaggle, doing some machine learning task or run some code segments in our Jupyter notebooks. From organization perspectives, we are dealing with tons of machine learning models. So managing the entire life cycle at scale is very complicated. Why I said so? So in organization terms, we have to able to document it, not just implement the whole code, managing the data, managing the code, managing the model environment, and managing machine learning models themselves. So they need established models and processes to developing and packaging and deploying the model, as well as the monitoring their performances in occasionally, and also we have to retrain them. So in most organizations are managing multiple models in production at the same time, adding a lot of complexities to it by adding new data, by adding new terms or matrices and performances. So a lot of teams are facing these kind of things, right? Cross-team alignment, silo team impaired workflow alignment and collaboration, and standards and repeatable processes, and resources and auditability. So as I mentioned in here, so for the cross-team alignment, as we know, right? So in the typical software development processes, we are using DevOps teams. And then for the standard and repeatable processes, we are using automated processes rather than reinvent the wheel again and again. And for the resources, we are using versioning. And for the audibility, we have matrices. We know, right? In ML, we have tons of matrices to evaluate our model. And then for the explainability, we could use many visualizations to interpret our model. So in these challenges, so those are very much similar for application development teams face when creating and managing their apps and software. To help, what we are using? Yeah, we are using DevOps. So the industry standard for managing the operations for an application development cycle to address these challenges with machine learning, an organization need a new approach to tackle those challenges and build the agility of DevOps to the ML lifecycle. So then we are calling it, yeah, MLOps. So we are moving ahead. So what is MLOps? It is a combination of machine learning and DevOps. So we could name it as machine learning operationalization. So it can be considered as a child of ML and DevOps. So MLOps is very crucial for companies which need scaling the AI across the many organizations, and it enables data science teams and IT teams, maybe the development team, to collaborate and streamline the machine learning lifecycle at scale for building model to deploy and management. So I'll just move on to give you some highlights. So what decision makers investing in MLOps? So the first reason, shall we pass out the previous link, please? Previous slide, yeah, perfect, thank you. So the MLOps is the process of building repeatable and verifiable workflow for our overall machine learning. And the reality in today, so people think about machine learning as just building, not just building a single model, but that's not it. We are to manage whole learning pipeline. So we need cloud as well. So and then when you think about our production pipeline and going end to end, we have system that understand how to deductively deploy each step of machine learning. And then reading, writing metadata. As I said, we need a proper way to manage all of the models, our code environment and code libraries, our documentation and all. So managing entire life cycle is very much difficult. So decision makers in very much half of the environments in organization are currently moving up MLOps with their data science and ML operations. So MLOps processes are help for us to actually tools are valuable for users to end-to-end ML lifecycle. They provide single place to people to collaborate and visual visibility throughout the share auditable documentations, like ability to save and track changes and create efficiencies and accelerate the whole ML pipeline with automation and repeatable workflows using reusable assets. So still, if you are not trusting myself, so let me give you a very famous example with related to Microsoft. So how MLOps in production? Actually, let's talk about the real world example. And actually, a transit agency for Vancouver, Canada. So they partner up with Microsoft to create a solution to improve the bus scheduling and develop more than 18,000 models to predict accurate departure time across different buses in different routes. So guys, we are talking about not just only one model, we are talking about 18,000 models. So managing that much many models are not actually feasible if we haven't able to do MLOps kind of a process or kind of a tradition. So because we are adapting with MLOps strategies, it allows them to automate the whole training part and then approve the process. We are the right people, had the right chance to look at the things before the rolling out, and then they integrated the drift system into our pipeline. So then after, they could able to achieve 74% batch departure prediction in terms of machine learning model. That's kind of one of the best accuracy you can achieve. And also they would able to achieve around 50% of less waiting time. Yes. So in this case, we are moving about another very quite interesting use case to tackle whether we could do a good accurate decision about diabetic classification to predict a person is having or suffering from diabetes or not. So just to give you a quick overview to the data set, there are few features. And so moving up to the next slide. So we are having patient ID, pregnancies, plasma glucose, blood pressure, and tricep thickness, serine, and BMI, diabetes pedigree, and age and diabetes. So first 11 attributes are actually our features, and the last one, which is diabetes, which is usually depicts in either 0 or 1, that is our label. That is what we are trying to predict. Yes. So with that, I move up to again with Fathiha to build the model creation. Yes.
Such an interesting overview on MLOps. And so now yeah. So now let's move on to our model deployment with Azure Machine Learning Designer. So whenever we are trying to create our own model, what we have to do is our first step would be stepping up and setting up an environment. So in Azure, the first step we are going to do is creating a resource. So here in our case, we will be going ahead with the Azure Machine Learning resource. So we are going to go ahead and create a new resource. And we can select an existing resource group from here, or we can go ahead and create a new resource group. So I will just go ahead with my existing resource group, and we can give it a name like, okay, we do not have to be bothered about the rest of the entities. So let's go ahead and create our resource. So it will be taking a little bit of time for, okay, so let's create. Just to save up some time, I have created my resource beforehand. So I think we should go ahead with that one. Okay, so yeah, you must have to pick an account and register before using Azure. Okay. So that was the steps how we should deploy a resource. But for the time being, let's go for the existing resource. So I'll be just going ahead and create a studio. So this is how Azure Machine Learning Studio looks like. And before creating any machine learning models, we must create compute resources. So here I have a compute resources created beforehand. So whenever you're working and suppose you have already deployed your model, you must remember to stop the resource, because keeping on your resource on run, it will cost you a lot. So I will be just going ahead and start my existing resource, and let's just show how to create a compute instance. So you can either choose a virtual machine's CPU or GPU. So for today, I'll be going ahead with CPU, and you can also select your virtual machine size. So let's go for TS11 version 2. So here in the category, you may see some categories like memory optimized, optimized, or general purpose. So in case of memory optimized, we will have greater memory size than CPU, and in case of compute optimized, we will have greater compute resources than memory, and in the general purpose one, we will have a balanced one. So now let's give it a compute name. So okay. Is that would be fine? Yeah. So let's create our compute. So after creating a compute, we need to have a compute cluster. Here we can see that we already have a compute cluster, but let's see how to actually create one. So, okay, let's go ahead. So in my case, I'll be going ahead with a dedicated virtual machine tier, and yeah, everything else is the same. So we will be giving it a compute name. So and we can set the maximum nodes to 2. Okay, for the time being, let's just stick to 1. Okay, and yeah, let's go ahead and create. So yeah, we can see that our compute instance is on run. So now let's head to our designer. And one thing before going to the designer, we must secure that our dataset is already uploaded. So here in my case, I have already uploaded my diabetes dataset. So I'll just go ahead into designer, and we'll just create a new pipeline. let's just quickly set a name. The first thing we need to do is to drag and drop our data set onto our designer. And after we have our data, so let's just visualize our data, because whenever we're working with data, exploring the data set before any sort of processing is a must. So we must know what's in the data, right? So here we can see that we have some columns. So we call the columns as feature, and every of the row that we have is an example. So here we have patient IDs, pregnancy, and every of the instances that Sahan already mentioned. And lastly, here we can see a column which is named diabetic. So this is our label data. So if you try to recall, we have already talked about label data set or unlabeled data set, right? So now from here we can see we can say that today we are going to work with supervised machine learning. So yeah, we are all set with the data. Now let's go ahead and normalize the data. So you may ask that what's the need of normalizing the data, right? But for example, here we saw a column named patient ID. Does the patient ID even it does it contribute even a bit with the patient to be diabetic or not? No, right? So the patient ID, it has nothing to do with the patient to be diabetic or non-diabetic. So we are not going to add that while normalizing our data set, but we are going to go ahead and select the ones that pregnancy, plasma glucose, diabetes, diastolic blood pressure, tricep thickness, serum insulin, BMI, diabetes, pedigree, age. But are we going to go ahead and select diabetic? No, because that's our label data. So yeah, after we have our data normalized, what we will do is to split our data. So we will be splitting our data. Yeah. After splitting the data, in usual computer science language, we call it train test split. So we give a certain portion for training and certain portion for testing. So here, what in Azure Machine Learning Designer, we have another very plus point, and that's we can even compare to algorithms. Suppose in this case, what algorithms can we use for the diabetes data set to predict the diabetes? We can use 2-class logistic regression, as we already discussed, and we can also use 2-class boosted decision tree. So from here we can see that which of the two algorithms performs better. So yeah, we will be going ahead and splitting the data in a 60% and 40% of portions. And yeah, we have our algorithms. We will be splitting our data. And now what we'll do, we will be training our model. So yeah, we will be training our model. So in the train model, we must specify what is our label data. So we have talked about it, and it was diabetic, right? So yeah, so just to save up some time, I can show you the previously created model so that it would be better for us to visualize. So yeah, let's go for this one. Yeah, our compute cluster provisioning succeeded. Okay. So here we can see everything we just did. We just dragged our data set and then we normalized it. We split it based in 60% for training and 40% for testing. And then we selected two of our algorithms, 2+ logistic regression and boosted decision tree. We trained our model, we scored our model, and lastly, we evaluated our model. So let's see what evaluations we got for that. We just have to go to jobs in, yeah, Here we can see that every of the steps were completed perfectly. And let's visualize what evaluation score did we get. In the left port, we had 2-class logistic regression, if you remember. So for that, we have a ROC curve, we have precision recall curve, we have lift curve, and we can also flexibly select the threshold according to our whichever we prefer. So let's stick to 0.5, and we can see that the accuracy we got for selecting this 2-class logistic regression algorithm is 78.9. So that's a very good, not a very good, but that's a good accuracy we can get from an ML model. So there are so many other information. Here you can see a 2x2 grid. Here we can say that there were 827 people who were predicted as diabetic and they were actually diabetic. So it's our true positive score, and therefore we can see that there were 2,300 people who were not diabetic, but they were also predicted as non-diabetic. So this is our true negative score. And we can also have these two errors are false positive and false negatives. So let's look at what we got from the right port, which was 2-class boosted decision tree. So here on the same threshold, we got the accuracy of 95.7%. That's incredible. So that's the beauty of using decision tree. So you are using the algorithm which iteratively works. And yeah, from here you can see the option of creating inference pipeline. And here, if you select the real-time inference pipeline, you will be deploying your model as a real-time inference. And yeah, you can deploy it as a web service and whichever you prefer. So from here, I would like to pass the floor to Sahan. Yeah, he can just go ahead and show you how to infer from a model with Azure Machine Learning Designer. So Sahan, are you there?
Yeah, so our newly hired data scientist Nur Fathiha has done a very amazing job of building the model creation. So let me get back to the slides again. So by now we have a model in our hand. So if I ask you the question, why do we to deploy? So the reason why we need to deploy it, basically in order to infer our data from our created model. So what are the things that Azure brings us in order to deploy our model in Azure? So the first thing is we can gain scalable on-demand compute service, and also the data storage and connectivity and ingest data from a wide range of sources, as Fatiha did. He just drag and drop the data set for model creation part, and then the machine learning workflow and the orchestration and automate the model training and deployment and manage the processes. And the model registration and management, you could track multiple versions of the same model with the differentiation of the data which they were trained, and also the matrices and monitoring for training the experiments and dataset and publish services. By now, as Fatiha did, we carefully inspect all of the experiments and write ROC values, accuracy, recall value, F-score value. We all did inspect all of these values. So we can did all of the things using Azure. And also the ML deployment we are going to do in a second by using real-time and batch inferences. So beforehand, it's good to have a quite a good, not an expert knowledge, a rough understanding about how we could maintain a workspaces and how you could use machine learning studio which provided by Azure. So moving to the next slide. So basically in Azure, the layers are respect in debits like this. So basically we are having a workspace. It's like our machine. So as debates in the previous slide, so we have an isolated workspace where we have our own computes and our notebooks and our pipeline and data and experiments and our models. So we need the help of the storage account in order to ingest our data, and application insight in order to visualize our data, and keyboard and container registry in order to properly versioning our systems. And in prior to that, we have a resource group and then subscription, and then after Microsoft Azure. So moving along, and so this is somewhat a rough usual dashboard you gonna see in Azure Machine Learning Studio, and I just put it to give you a highlight, give a better intuition about the whole dashboard on provided by Azure. And then, so we are very safe to move ahead to do the ML workflow. So what are the steps? So as an infant, you may are very good at ML, but you are maybe an infant to do when it comes to ML deployment. So don't worry. These are the steps you have to follow. First, you have to register your model. For in this case, I have the model of Fathiha, and I'm going to register that model and prepare an entry script, and then prepare an inference configuration. So we are configure in order the way the model should act in our application, and then we are deploying the model locally to ensure everything is works fine in our environment. And then we are choosing a compute target, that's maybe a REST endpoint, maybe our production environment or application, and we are deploying into model to cloud. And yeah, that's it. We are very much safe to test your results. So by now, what's your impression after seeing this last slide? There are tons of steps, and what's your impression? Let's comment out in chat section. So you may be in the uh, column 1, and you may be at column 2 again, and you may be at column 3, which is your very super exciting phase. Yeah. So let's move on. So as I said, we are using a diabetes data set. So there are tons of attributes we are taking into account. So ultimately, we are checking that if we are giving an unforeseen data set for the model itself predicting that whether the person is having or suffering from diabetes or not. Yeah. So and jump up 2 slides. Yep. As Fatih did, this is somewhat a very high level overview that what Fatih did. If you are very much familiar with your Python based environment, and this is what she did. So first we load the data set, and then moving, we are separating the features and labels, and then moving up and moving up. So we have feature selection and train at test. We are splitting both data set into train and test, and we are training the model and evaluating it, and just it. We are ready to move on to deploy our model. So as I said, this is what we need to deploy our model when it comes to inferencing. So it is just one good example I can give you is it's like ChatGPT. So we are just prompt what we need, and model itself give our results. So jump up again 2 slides. Okay. And before moving, I just recommended these kind of steps for you. And the basic Python knowledge is a plus. Actually, we are basically using Python for ML development and all. So it's not the must, but it's better to know about Python. So if you are a beginner to machine learning, the domain of ML, so it's a very good starter point to learn about Python. It's a very good plus. And then you will need Azure subscription and Azure Machine Learning Workspace. And in terms of compute instances, I recommend you all to integrate standard DS11 version 2 or higher. If you are very much sure about your compute instances, it's okay to use any instances which provided by Azure. But if you are a newbie or an infant, I recommend you guys to use standard DS11 version 2, which very flexible, and it gives somewhat sufficient compute resources that you need to run many tasks that you want to do. And yeah, so I just created my own repository. So if you have access to the GitHub, you could straight away go to move to this link, and all the implementation are contained there. So you just have to fork that repository for you, and just you need to pump it to the Azure. So as I said, the first step, you have to register your model in the model registry. So why we have to register our model? So as I said, there are tons of versions of our same model, so we have to version it. So by registering our model, Azure itself managing all the version of itself. So it's help to keep track of all trained models of a machine learning workspace at real time. Then we'll be able to load when you are required and whenever required based on your requirement. And this is somewhat a code snippet that you have to register the model. In step 2, this is somewhat a very important step throughout the pipeline of defining and deploying your model. Actually, in defining the inference configuration, there are two important things that you have to keep in your mind. First, there is an entry script, and you have to define your own environment. Actually, for that, in the next slide, you could see in the entry script, we are defining two main functions called init function and run function. Basically, in init function, we are initializing our model by the registration of a model in the step 1. And then in the run method, actually, we are calling the initialized model, which the data it is submitted. So in the demonstration section, I will thoroughly go through the whole code. You will eventually understand. And then the second step, which we have to define our own environment. So environment itself, there can be many tons of environments that you can configure for your ML model. So whether you can have a PyTorch environment, whether you can have a Keras environment, or you can have a very simple Python environment that contain the required packages for your model training and deploying. So in the environment section, basically you are providing the essential contains libraries and dependencies that your model needs. So then after we are moving to the step 3, so which is the most important one. So we are defining the deployment configuration. So in this case, there are tons of options that you can follow. So in this demonstration, I will use ACI web service, which is Azure Container Instance Web Service, because it's very lightweight. And since since Fathia also using one instance, so it's very safely move on with ACI web service. But if you have in mind to use mini compute services like a cluster of compute services, you straight away go ahead with AKS cluster, Azure providing you a separate entity for deploying configuration as AKS cluster. So beforehand, it is a must to have a cluster as your compute service for your compute target before deploying. And then that's it. You could deploy your own model. After all configurations are prepared, you can deploy. So the easiest way is to call the deploy model of a class like this. So you have to just mention a function, a Python, very simple Python function called model.deploy. So basically defining your workspace, your name, and your models, which model you are integrating with in order to do the deployment, and deployment configuration, which we have initially defined, and the compute target. And that's it. You're good to go to do our model deployment. And then after, yeah, as I said, so yeah, so then after we are just checking whether I'm just give you the high level intuition before I'm moving up to the demonstration, so I can clearly trace it. This is why I'm set in this step. So in step 5, so we are, yes, okay, so we are good to go. We are successfully deploy our model in locally, so we are ready to consume it locally. So in this point, we are creating a web service to a run method of web service object that we can reference to the deployed service. So typically we are using a JSON format, as if you are very familiar with Postman, this is somewhat very similar, and you are very much familiar with JavaScript, and also you could understand this code. So basically we are using a JSON structure to pump up our inferred data, and model itself return a JSON return request based upon our prediction. And step 6, you could use a REST endpoint to infer the service. So most of the time, many clients and many application development engineers are using this kind of a REST endpoint to infer the service, because REST is very widely adopted technique for the REST API development. So it's, in terms of students, it's better to know about how to create your own REST endpoint to infer the service in terms of machine learning. Yeah, we are very much good to go with our demonstration. And after I jump up from the demonstration, I'll give you a quick note about the compute targets. Let me share my screen. Hope it's visible. I think Fathiha can confirm if it's visible.
Not yet.
Yeah, okay, perfect. So you just need to create your own ML machine learning studio just after a successful
Sahan,
creation.
we're not seeing your screen, so can you just reshare your screen, please?
Okay. Hope you could see it.
Okay, I can see it now. Thank you.
Okay, so perfect. So just after successful creation of Azure Machine Learning Studio, you have tons of options as you may have seen in the left-hand side. This is where you can author in your own notebooks and do, if you are very in front of the machine learning services, you could use automated machine learning, or as Fathiha did, you could use Azure Machine Learning Designer. But in this case, we are just doing some sort of a very uh, techie thing in terms of machine learning. I'm using my own notebooks. And also, these notebooks are freely available in DP aks.ms DP100 learning path. I'm just following the same path because if you are very interested about this demonstration, you could clearly follow this step because it's similar and it's very easy for you to adapt for the same demonstration. So in there, and we just defining our ML environment, and we just train and our registration our own model. So this is the part we are very much interested with. Uh, we are registering our model, and we are giving the path where we are building our own model. Yes, it's successfully completed, and we have around 88 accuracy with the AUC value of 0.87. Wow. And then we are deploy our model as a web service, which is our third step. We are now moving to and ready to inspect our configuration files. And then after, as you may have seen in this snippet of code, we have 4 versions of our same model. And what assured it is, it gets the latest model, which is our version 4. So, and then we are setting up our deployment folder. And this is somewhat additional configuration that you have to do in order to do the deployment part. And we are giving the script file which contains our scores of our diabetes data set. And then after, we are defining our configuration files which contain the init function and also the run function, as I have mentioned in the slide deck. So it contains the initialization, and when we are doing a request, this is the function that going to invoke, which contains the predictions. And then after, we are configuring our own deployment configuration, which contains all the deployment dependencies that we are telling to Azure to take this kind of an environment for my deployment. And this is the entity script that I have defined. And this is the source directory that you have to take my model into my deployment. So in this case, I'm just using Azure ML Scalant 0.24.1, which is a VM on top of Ubuntu OS. And then, we have successfully created our model. If you have succeed in the deployment, you should see this successful message and also see the your model in healthy state. So as I said, in this demonstration, I'm just using ACI service, which abbreviated for Azure Compute Instance Deployment Service, to create and deploy our model. And then after, I'm just log it. What are the things that I have done in terms of software development? And this is kind of a good practice that you can build in order to keep a separate log file. So in order to reverse it back, or if you need to revert it back, so log file is kind of an treasure for you. So yes, you could find many details in your log files. So then after, we are very much good to move with our diabetes service. So in terms of this, we are using a web service, so we could easily inspect our service. And I'm just passing a single entry which contains the same feature set that we have provided for Azure to train our model. And for the inference part, we should give to the model, if I have this kind of an instance, what would be the result, whether the patient is diabetic or a non-diabetic person. So this is the thing that I have demonstrated in this part. So basically, I am defining a vector which contains with different values of a certain patient, and then I'm inspect it using my service, created service, and then run with the newly created input dataset. And after getting the predictions, print it. So this is the patient, and this is the result. So this kind of patient got diabetic. And think of an instance like we need tons of data. We have very set of data and set of array. You could define it as an array. So as I did it here, and let me just add another entry. Okay, let me just update this value for 59 and just update it to 41. Okay. Okay. What a silly mistake. Perfect. So for the first patient, it is he or she is a diabetic person, so it's better to take the medical advices. For the rest of the people are safe from diabetes. So if you want to infer, so our product is live. So you could take this endpoint, and if you just passed, and if you have tools like Postman or some API request, you could share this in your web and checks whether it's perfectly working as per your for your production purposes. So this is somewhat we are trying to tell you starting from the beginning. We are just registering our model, and we are defining all the adequate inference and configurations, and then we are build our model locally, and then we are building our own web service which could take any kind of an prediction or around the world. This is the endpoint. So if you have the access, just get this link. Yeah. So it's kind of a very messy one. Actually, if I could convert it a bitly, I could straight away pass it to. But if you paste it this link in a new tab in your Chrome, you could inspect anything that you need to inspect from our creative model. So that's it. Again, these are kind of an somewhat other additional codes that you can try it out, and what kind of a result that you can gain from the deployed model. So we just made a post request from our just created REST API point. So we just need to do a post request, guys, not a get request or a put request. We have to do a post request in order to get data from our model. And we just need to mention about our endpoint and the input JSON. JSON is based upon what kind of a model we are going to access from the backend, and then the header files. Just these are additional configurations. Yes. Yep. Let me just pass it back for the slide deck to end up the demonstration. Yep. So I'm stop sharing, and I could see the Fathiha slide deck. Yes, let's quickly move on to the last part. Yeah.
So You might need to reshare or let me know where you want to be at with the deck. Fathiha, your screen didn't share anymore.
At the same time, if you have any sort of a question, please drop a message to the YouTube stream so whether we could reach out to you.
And you're just on mute, Fathiha. Okay.
Oh, I just totally forgot.
That's okay.
Okay,
Yeah.
so a quick note about the compute targets. So there are four options that you can take into account when you are deploying your own models. But personally, I recommend you guys to use the bottom three options, whether Azure Machine Learning Endpoints or Azure Machine Learning Kubernetes Service or Azure Machine Learning Azure Container Instance. So in this demonstration, we are using Azure Container Instance, and it's perfectly better for you if your application is not much consumed by many clients. You are not much using where of compute resources, but you have a kind of a very heavy model. I recommend you guys to use AK cluster. Okay. Moving on. Yes, this is how you can deploy to cloud and inspect using Postman. And yes, with the time being, I guess we are not ready for do the orchestration part. So yes, Fatih, shall we end it up?
Yeah, let us just quickly review
So
some of the cost management tips, because whenever you're working with Azure, make sure to configure your training clusters for auto scaling. So for that, you just have to set your nodes to 0 and it will be automatically scaled down when you're not using the resources. And also you can set quotas if you have multiple subscriptions and workspaces. And yeah, uh, you can use low priority VMs, and you can also set termination policies when you're training your run. And lastly, you can also use as your reserved VM instance. So some other things I would like to mention, that don't forget to stop your computing resources. Like for me, it happened once that I kept my compute instances running, and after like 7 to 10 days, I had something to work on, and I came back and saw that $100 of my are gone. So yeah, don't forget to stop your compute resources and delete your workspaces if they're not necessary. So there are some resources that you can have a look. And yeah, we are ready to take any question if there is any.
So there was a question from Matt. Is the notebook and model and GitHub accessible to play with?
yep, let me just drop the GitHub link to Michael. So
No worries. We'll paste that into the chat. And that was the only question that we've got. If anyone else wanted to ask a question, otherwise we will wrap up. But I am so grateful to have both of these incredible ambassadors joining us from different parts of the globe. I'm in Sydney. They're in different parts of the world as well. So it's just such a unique opportunity for us to have everyone together on this. So thank you both for joining us. I've shared some information about the Microsoft Student Ambassador Program. If you are interested in that in more detail, please take a look at that. I'm just going to paste that link into the chat there that Sahan has shared. But other than that, I would like to wish everyone a wonderful evening, good morning, good day, and we look forward to seeing you all again soon. Thank you, everybody.
bye. Have a nice day. Bye bye.
Thank you.
Have a nice day. Goodbye.